Hello, so let's start the maximum product subarray question. And this question is one of the most asked questions in like Kadane's based pattern. So let's start off the brute force solution. Like what you can think of the brute force solution, like we can generate all subarrays and then keep track of minimum product of subarrays, and we return the length of the subarray which has the minimum product. So let me start with the implementation part. Like we are basically gonna take a variable n for the array dot size, and we are basically like traversing, like using double for loop, like for int I equal to 0, I less than n, I plus plus. This is the basic template for like generating all pairs of sub arrays. And for j equal to I, j less than and j plus plus. Yeah, we are like for each I we are calculating the product. So here we are gonna initialize the product variable with 1, and for minimum track, sorry, in for maximum track, int max prod will be like int main. So yeah, this is like, and then we need to like calculate on the go the product for each subarray starting from I. So like in product into equal to array of j, and now we are basically going to update the max product equal to max prod comma prod, and at last we need to return the max product, return max prod. I hope it runs fine. Sorry, here int will be there. Yeah, you can see it running, but it will give us the TLA since we are running two for loops, like it will be a complexity of n square. So how we are going to optimize this? It is not like as much simple as we have discussed for the like maximum sum maximum subarray sum. Likewise, so we are basically need to like have an approach for like let me give you an example first. Yeah, like this was the case, we have given an example nums array. So like there can be four cases which needs to be explicitly handled. Like if all the values will be positive, then overall our product will be positive. So no need to explicitly handle any negative or zero values. But if we have even number of negative values, then also we know the product will be like minus into minus will be a like plus. So it will be also fine. But when there is a case of negative number of sorry, when there is a case of odd number of negative values, then our whole value can be negative, and for zero we will handle it explicitly after that. So like uh, so yeah, so in this for this optimized approach, we basically prefer like keeping a track of the product from the beginning and from the end. Like how, why are we gonna do this? Because negative values and zeros can like invalidate your prefix or suffix, because like if you multiply it with 10 into 0, it will become overall 0. So basically we need to handle that also. And yeah, like it is not like a intuition, like yeah, it seems like an intuition, but you have to remember this specific problem, because some problems are like you have to remember them, how to approach them. Like, so let's start this approach. And yeah, one more thing I need to say. Okay, let me implement first, then I will tell you. So we are basically gonna keep track of the product from the beginning with the variable prefix, and from the backward with variable suffix. Now int n equal to array dot size, we are gonna simultaneously calculate the prefix and suffix. We can do it also in another path, but it will be like two pass solution, but we want like one pass. So we are gonna calculate prefix as well as suffix in one go only, like I less than n, I plus plus. So 0 case we will handle, but before that let's do remaining thing like prefix, prefix into equal to, or let me like clear, prefix equal to prefix into array of I, and suffix equal to suffix into array of n minus I minus 1. You know why we are doing like n is the overall, let me, yeah, here 3 3 6 7 is the size, so we are basically taking the index sixth one. So uh, that's why we have taken like n minus I minus 1, because for I equal to 0, n minus 0 means 7 minus 0 minus 1, it will be 6, like it will be getting the last value. So after that, yeah, we basically have to calculate the max of, we have to basically keep track of the max product here, prefix comma, oh sorry, max of prefix comma suffix, and at last return the maxi. So like int maxi equal to int me. One more doubt you will be having, like why we are taking the prefix and suffix max. So let me show you. Yeah, so like here you can see, from when we start from the prefix like 1 into 0. Okay, let me first write the 0 implementation part, then you will better understand. Like if we gonna, sorry, if anytime we are gonna meet with 0, basically we will reset the entire prefix with the 1. Same for the suffix, reset suffix with 1. Yep. So like here we have handled that case also, and let me show you the dry run how it can work. Like prefix equal to 1. After that, when it is multiplied by 0, it will be overall 0. So we will be update the prefix with 1. So 1 into minus 1 minus 1 minus 1 into 2 minus 2 minus 2 into 3 minus 6 into 5, 30 into minus 2 minus 60. If you have got the sum, sorry, product as 60 from left to right, and when we traverse from right to left, it will be minus 2 minus 5 will be 10 30 60. Yeah, here you can see till here we have got the product as 60. So we're basically gonna keep track of the maximum of the prefix and suffix, because if we go forward like 60 into minus 1, it will be minus 60. Again with 0, it will be like become 0. So basically we are keeping track of the maximum of the prefix and suffix, and we are storing it basically, and at last we are returning the maxi variable. So yeah, it is running fine. And talking about the complexity, it will be like big of and solution, since we are using a single for loop. So I will say like, uh, remember this approach, because there are some questions in which you need to remember like how to approach that problem. So thank you for watching, and in next video I will like cover more Kadane's pattern problem.